Hi everyone, in this video we look at how to simplify powers of I. So first off we have I squared, which we've already defined to be -1. Well, actually we've defined the square root of -1 to be I, and if we square the square root of -1, we should get -1. Next, if we have I to the power of 3, well, remember that this is I times I times I. That's actually what I to the power of 3 means. So if I multiply I times I get -1. So I've got -1 times I, and we would just write this number as -I. Next we've got I to the power of 4. So I to the power of 4 is equal to I times I times I times I. So that's equal to I times I, which is -1, times I, and I times I again is just -1. So I to the power of 4 is equal to -1 times -1, which is +1. Now let's think, do I actually have to write out I times I times I times I every time I have I to the power of 4, or is there maybe a simpler way to do this? Well, remember that in the imaginary number system, our rules of arithmetic still have to apply. So if I do I to the power of 5, remember that I can rewrite this as, using the exponent laws, I to the power of 4 times I, because I've got 5 factors of I. Well, I already discovered that I to the power of 4 is just 1, so this is equal to 1 times I. 1 times I is just I. So I to the power of 5 is just I. Let's try I to the power of 6. Well, I could use the fact that I to the power of 5 is I. So I could write this as I to the power of 5 times I. I to the power of 5, I already discovered was I. So I'd have I times I, which is equal to -1. But let's think to ourselves, is there an even easier way to do this without knowing what I to the power of 5 is? Well, if I think about this, I can use the exponent laws, and I could have written this as I to the power of 2 to the power of 3. Because when I have a power to a power, I multiply the exponents, and if I multiplied the exponents here, 2 times 3, I would get 6. So I to the power of 2, in brackets, the power of 3 is I to the power of 6. But we already know that I squared is just -1. So I've got that this is equal to -1 to the power of 3. Well, -1 to the power of 3, anytime I raise -1 to an odd exponent, I get a number that is negative. I get -1. So I to the power of 6 is going to be equal to -1. Next, I've got I to the power of 10. Well, let's think about this. How can I rewrite this? Well, I to the power of 10 can be rewritten as I squared to the power of 5 using the exponent laws, because 2 times 5 is 10. I squared is -1 to the power of 5 is equal to -1, because -1 to the power of an odd exponent is negative. Next I've got I to the power of 100. Well, let's think about this. I can rewrite this as I squared to the power of 50, because 2 times 50 is 100. I squared is -1, and I've got -1 to the power of 50. Well, -1 raised to an even exponent is a positive number, or it's +1. So I to the power of 100 is 1. Next we've got I to the power of 101. Well, this one's a little bit trickier, but I already have that using the exponent laws, that I to the power of 100, I already know, times I. Well, I to the power of 100 was just 1, so 1 times I can just rewrite as I. So you can see that there's a pattern, there's a definite pattern here when we're raising imaginary numbers to different powers. So I'll let you guys go ahead and you can try to define what that pattern is on your own, and we'll see you in the next video.